Imagine diving into the depths of an ancient ocean. The water around you is dark, mysterious, and teeming with life. But this isn't just any ocean. It's a prehistoric realm where danger waits at every turn. We've all heard of the mighty megalodon and the fearsome mosasaurus, but they're just the tip of the iceberg. Let's meet 5 of the most terrifying sea monsters you've probably never heard of. Our first stop on this underwater odyssey takes us further back in time than you might have thought possible. Over 500 million years, to be precise. Welcome to the Cambrian period, a time when life on Earth was undergoing a revolution. The so-called Cambrian explosion was in full swing, with new body plans and survival strategies evolving at a breakneck pace. In this alien world of prehistoric oceans, one creature stood out as a true pioneer of predation. Meet Lyrarapax unguispinus, whose name translates to spiny-clawed lyre-shaped predator. Picture, if you will, a creature up to 3 feet long, which doesn't sound too scary until you realize that most life at this time was mere inches in size. Lyrarapax had a segmented body reminiscent of a lobster with multiple pairs of legs that it used to swim through the ancient seas. But it's the head of this beast that would give you nightmares. Sprouting from its face was a pair of massive claw-like appendages called great appendages. These weren't just for show, they were precision hunting tools, capable of grasping prey with deadly accuracy. Imagine a pair of serrated knife blades attached to a lobster's face, and you're getting close to the terror that was Lyrarapax. So what made Lyrarapax truly special was its place in Earth's history. This creature was one of the world's first apex predators, a pioneer of the predatory lifestyle that would come to dominate Earth's ecosystems for hundreds of millions of years to come. In a world where most life was small, soft-bodied, and relatively defenseless, Lyrarapax was like a living weapon, a harbinger of the arms race between predator and prey that continues to this day. As we leave the Cambrian behind, our time machine takes us forward to the Triassic period, roughly 250 to 200 million years ago. The world has changed dramatically. The supercontinent Pangaea dominates the globe, and the oceans are teeming with new forms of life. Among them, we find our next prehistoric predator, the peculiar and fascinating placodonts. At first glance, you might mistake a placodont for some kind of prehistoric turtle. They had broad, flattened bodies protected by a shell-like covering of bony plates. But take a closer look at their heads, and you'll realize these creatures were something altogether different and far more terrifying. Placodonts came in various shapes and sizes, but all shared one distinctive feature. Their mouths were armed with an arsenal of specialized teeth that made them the terror of ancient reefs. At the front of their jaws, they sported buck teeth reminiscent of a beaver. These protruding teeth weren't for gnawing on wood, though. They were precision tools for plucking shellfish from the seafloor. But the real horror show was further back in their mouths. There, placodonts had rows of flat plate-like teeth that worked like built-in nutcrackers. Once they plucked a shellfish from the reef, they'd move it to the back of their mouths and bring these crushing plates together, pulverizing the hapless mollusk shell and accessing the soft, nutritious meat inside. Imagine a creature combining the shell of a turtle, the front teeth of a beaver, and the crushing power of an industrial press. That's a placodont for you, a perfect example of how evolution can produce highly specialized predators adapted to very specific ecological niches. Placodonts weren't just found in one small corner of the world either. Fossils have been discovered across what was once the Tethys Sea, an ancient ocean that covered much of what is now Europe, the Middle East, and China. This wide distribution shows just how successful these armored shellfish crackers were. One particularly fascinating member of this group was Henodus, a placodont that took the group's adaptations to the extreme. Henodus had an almost perfectly circular body, protected by a shell that made it look like a prehistoric Roomba vacuum. Its mouth was adapted into a vacuum-like structure, perfect for sucking up small prey from the muddy seafloor. Now, we're swimming through time to between 290 and 250 million years ago, to meet a creature so bizarre that it puzzled scientists for decades after its discovery. Ladies and gentlemen, I give you Helicoprion, the spiral-toothed terror of the ancient seas. Helicoprion was a type of cartilaginous fish related to modern sharks and rays. But if you're picturing a typical shark shape, think again. This creature had an adaptation so weird, so seemingly impractical, that it has become the stuff of paleontological legend. A lower jaw sporting not rows of teeth, but a spiral tooth whorl, like a circular saw made of nightmares. This whorl could contain up to 180 serrated teeth, arranged in a tight spiral that grew throughout the animal's life. When Helicoprion bit into its prey, this tooth whorl would rotate, slicing through flesh like a prehistoric chainsaw. For years, scientists struggled to understand how this tooth whorl worked. Early reconstructions placed it on the outside of the jaw, like some kind of bizarre elephant trunk. Others thought it might have been inside the throat. It wasn't until recent years, with the help of advanced CT scanning and 3D modeling, that we got a clearer picture of how this living buzzsaw actually functioned. The latest research suggests that the tooth whorl was housed inside the lower jaw. When Helicoprion opened its mouth, the newest, sharpest teeth at the end of the spiral would be exposed. As it bit down, the whorl would rotate, drawing prey further into the mouth while the teeth sliced it to ribbons. It was a feeding mechanism unlike anything alive today. But what did Helicoprion eat with this crazy tooth whorl? Fossil evidence suggests that it primarily hunted soft-bodied prey, like squid and other cephalopods. The rotating action of the whorl would have been perfect for grabbing onto slippery tentacles and drawing them into the mouth. Helicoprion wasn't small either. Estimates based on fossil tooth whorls suggest that some individuals could have reached lengths of 25 feet or more. Imagine a predator the size of a great white shark, armed with built-in circular saw in its mouth. It's the stuff of prehistoric nightmares. We're traveling back 390 million years to a time when life was first beginning to venture onto land. But we're not here for the terrestrial pioneers. We're here to meet one of the most formidable creatures ever to swim in Earth's oceans, Jacalopterus rhenania. Jacalopterus was a member of a group called the Eurypterids, better known as sea scorpions. But calling Jacalopterus a sea scorpion is like calling a tiger a big cat. It doesn't quite convey the sheer terror this creature could inspire. Imagine a scorpion the size of a crocodile. Jacalopterus stretched over 8 feet long, making it one of the largest arthropods ever to exist. Its body was covered in a tough exoskeleton, providing formidable armor against potential predators. Not that it had many to worry about at its size, but the true terror of Jacalopterus lay in its front appendages. It possessed a pair of massive, pincer-like claws that it used to snatch prey right out of the water. These claws were lined with sharp, serrated edges, perfect for gripping slippery fish or tearing into the soft bodies of other marine creatures. Imagine swimming in a prehistoric sea and seeing this monstrous arthropod coming at you, its giant claws outstretched. It's no wonder that Jacalopterus was likely the apex predator of its time and place. But size isn't Jacalopterus's only advantage. Like modern arthropods, it likely had compound eyes, giving it excellent vision for spotting prey. Its segmented body would have made it a powerful swimmer, able to dart through the water with surprising speed for its size. One of the most fascinating aspects of Jacalopterus is what it tells us about the history of life on Earth. This creature existed at a time when the largest animals lived in the seas. It would be millions of years before vertebrates on land would reach comparable sizes. Our final stop on this journey through prehistoric seas brings us to more familiar waters. The late Cretaceous period, around 145 to 66 million years ago. The age of dinosaurs is nearing its end, though the creatures living at this time have no way of knowing that. Among them is our final prehistoric ocean predator, a creature that seems almost mundane compared to the bizarre beings we've encountered so far, but is no less fascinating. Hesperornis. At first glance, Hesperornis might not seem like much. It was a flightless bird, similar in many ways to modern diving birds like loons or grebes. But don't let its seemingly ordinary appearance fool you. Hesperornis was a highly specialized marine predator with some surprising adaptations. Picture a bird about the size of a goose, but with a long, slender neck and a head that tapers to a pointed beak. Its wings were reduced to tiny stubs, useless for flight, but possibly helpful for steering underwater. Its powerful legs were positioned far back on its body, much like a modern penguin, making it an excellent swimmer, but awkward on land. But the truly remarkable feature of Hesperornis was hidden in its beak. Unlike modern birds, Hesperornis had a mouthful of sharp, pointed teeth. Hesperornis used these teeth to great effect as it dove underwater in pursuit of fish. It could likely dive to considerable depths, using its powerful legs to propel itself through the water and its toothed beak to snatch up slippery prey. Fossil evidence gives us a remarkably clear picture of how Hesperornis lived. We've found fossils of these birds with the remains of fish preserved in their stomach areas, showing us exactly what they ate. We've even found fossils of baby Hesperornis, giving us insight into how these creatures raised their young. But life wasn't easy for Hesperornis, despite its impressive adaptations. The late Cretaceous seas were a dangerous place, filled with large marine reptiles like mosasaurs and plesiosaurs. Fossils have been found showing bite marks from these larger predators on Hesperornis bones, a stark reminder that in the prehistoric oceans, even the hunters could become the hunted. Hesperornis is a fascinating example of convergent evolution, the process by which unrelated organisms evolve similar traits in response to similar environmental pressures. Though unrelated to modern diving birds like penguins or loons, Hesperornis evolved many of the same adaptations for a life spent hunting in the water. Have you ever wondered what Earth was like 250 million years ago? It was a time when our planet was almost unrecognizable, with a single supercontinent, scorching temperatures, and some of the most bizarre creatures to ever walk the land or swim the seas. Our story begins with Pangaea, a colossal landmass that covered nearly a third of the Earth's surface, surrounded by the mighty Panthalassic Ocean. This vast expanse of water, derived from the Greek words pan for all and thalassa for sea, dwarfed the Pacific Ocean, spanning an incredible 140 million square miles. The Tethys Sea, a smaller secondary ocean, played a crucial role in shaping the world as we know it. This shallow equatorial sea separated Pangaea into two distinct landmasses, Laurasia in the north and Gondwana in the south. Located on the eastern side of Pangaea, the Tethys Sea was a hotbed of tectonic activity and played a key role in the formation of new ocean basins. The Panthalassic Ocean teemed with life, serving as home to a remarkable array of creatures, including early tetrapods, primitive sharks, and diverse invertebrates. As Pangaea gradually fragmented, the remnants of this ancient ocean gave rise to the Pacific Ocean we know today. Stepping into the heart of Pangaea, one would have been greeted by a scorching wall of heat, with temperatures soaring to a blistering 140 degrees. The supercontinent's center was a virtual oven, characterized by arid, rainless conditions exacerbated by mountain ranges that blocked life-giving clouds. Vast swathes of Pangaea were transformed into inhospitable deserts where only the most resilient creatures could survive. Ocean currents played a crucial role in shaping Pangaea's climate and environment. Although fossil evidence is limited, educated guesses can be made based on the Earth's rotation and wind patterns, which were essentially the same 200 million years ago as they are today. These wind patterns drove the circulation of surface waters across the globe. At the equator, converging winds from the north and south pushed water westward, creating a warm equatorial current that traversed the immense Panthalassa. Upon reaching the coast of Pangaea, this current split, with some water flowing north and some south. In the northern hemisphere, the diverted water cooled as it moved away from the equator, eventually circling back to form a large gyre. A similar pattern occurred in the southern hemisphere, with water deflecting, cooling, and circulating back to the east. On the opposite side of Pangaea, the equatorial current continued its westward flow, with the northern portion mostly deflecting downward and some water entering the inland ocean area. The southern portion traveled further, reaching the southern tip of Pangaea, where it split, with some water flowing back northward, warming in the process, and some continuing southward as a cold current before rejoining the eastward flow. Pangaea also experienced a yearly equatorial monsoon season, which brought heavy rainfall from Panthalassa into the Tethys Sea, a smaller ocean basin separating parts of the supercontinent. This monsoon season significantly impacted the climate and vegetation of the regions surrounding the Tethys Sea. The atmospheric composition, particularly the concentration of carbon dioxide, was another critical factor in shaping Pangaea's climate. Around 200 million years ago, average CO2 levels were approximately 1,850 parts per million, 5 times higher than today's levels and 6 times higher than pre-industrial levels. This high concentration of CO2 led to a greenhouse effect, resulting in global temperatures that were, on average, 3 degrees Celsius warmer than modern times. The warmer global temperatures profoundly impacted the Earth's environment. Fossil evidence from the North Pole, dating back to this period, reveals the presence of subtropical and even tropical plants, indicating that the polar regions were much warmer than they are today. There is also no evidence of glaciers or significant ice cover on Earth during this time, except perhaps in high mountain ranges, suggesting that the Earth was experiencing a greenhouse climate, where even the North Pole could have been covered in tropical rainforests, provided there was sufficient moisture. The absence of cold climates meant that temperature was less of a determining factor for the environment, making moisture the primary driver of ecosystem distribution. As a result, the lands of Pangaea were largely divided between two contrasting environments: forests in areas with high moisture levels and hot deserts in dry regions. In areas with moderate rainfall, narrow bands of tropical savanna served as transition zones between the forests and deserts. The distribution of forests and deserts in Pangaea can be understood by examining ocean currents and mountain ranges. Cold ocean currents contributed to low levels of evaporation and moisture in the atmosphere, resulting in minimal rainfall over adjacent landmasses. Therefore, regions along the coast with cold currents are more likely to be arid and desert-like. Conversely, warm ocean currents promote evaporation, leading to higher atmospheric moisture and increased rainfall over nearby lands, supporting the growth of forests. These patterns are still evident in modern times. For example, the cold ocean currents off the coast of California contribute to the arid conditions of the Mojave Desert, while the warm Atlantic waters flowing up from the Caribbean lead to a more humid climate in the eastern United States. Similar patterns can be observed in South America, Africa, and Australia. Unfortunately, the Panthalassic Ocean was in even worse shape. Aquatic life had been decimated by the extinction event, and the waters were still incredibly hot. Tropical temperatures could reach a scorching 104 degrees Celsius, making recovery a slow and arduous process. Yet, even in these hostile waters, new life began to emerge. The Ichthyotitan, ancestors of the mighty ichthyosaurs, were among the first marine reptiles to appear. These primitive creatures were small, typically less than a meter long, and swam in an eel-like fashion. The most common genus was Grippia, which had a widespread distribution along the coast of northern Pangaea. Another group of marine reptiles, the Sauropterygians, also made their debut during this time. These diverse creatures, which would eventually give rise to the pliosaurs, were small in stature, with the slender-bodied Chorosaurus being a prime example. Superficially resembling the Nothosaurus, these fish-eaters would have been a common sight in the shallow seas. Fish populations also persevered, despite the extinction event's impact. Permian survivors like the ray-finned and bony fish maintained cosmopolitan ranges, while the Paleoniscum underwent remarkable diversification, evolving new lifestyles to adapt to the changing world. Sharks, while suffering a decline in diversity, still clung to their roles as apex predators, with groups like the Hybodontiformes and Eugeneodontiformes leading the charge. Most sharks were under 5 feet long, but their global distribution and diverse diets made them highly adaptable. Some may have even ventured into freshwater rivers, posing a new threat to terrestrial animals. The Permian extinction, a catastrophic event that took place 252 million years ago, saw 90% of all marine life vanish in the blink of an eye. This mass extinction was caused by dramatic changes in the Earth's atmosphere, leading to a series of devastating consequences for life on our planet. The Panthalassic Ocean, a true behemoth, covered an astounding 70% of the planet's surface, stretching from pole to pole. It was nearly twice the size of the modern-day Pacific Ocean and had an average depth of 250 meters less than today's oceans. Despite its immense size, the Panthalassic Ocean had relatively simple and slow currents compared to the complex systems we see today. Evidence for the oceans of 250 million years ago comes from various sources, including geological observations, paleogeographic reconstructions, and studies of ancient environments and sea level changes. The presence of Panthalassa as the dominant ocean during this period is supported by a wealth of scientific data, offering a glimpse into a world that has long since vanished. Significant changes in sea level have occurred over the last 250 million years. Evidence of sea level rise and fall is well preserved in Permian rock layers, with fluctuations often linked to changes in climate. Some of these fluctuations were likely caused by glaciation or Milankovitch cycles, long-term variations in the Earth's orbit and axis tilt that can profoundly impact global climate patterns. Global sea level events marked by low stands, times when sea level falls below the level of the continental shelf, occurred within the early, middle, and late Permian epochs. These events were characterized by the widespread retreat of seas from continental shelves and platforms, resulting in significant gaps in the fossil record and extensive evolutionary turnover in shallow marine ecosystems. The Permian period was a time of incredible change and upheaval, from the formation of the Panthalassic Ocean and the Tethys Sea to the devastating impact of the Great Dying. This period in Earth's history was marked by a series of dramatic events that would forever alter the course of life on our planet. Despite the challenges and adversity faced by life during the Permian period, it was also a time of incredible resilience and adaptation. As the world around them changed, species evolved and adapted to new environments and new challenges, laying the foundation for the incredible diversity of life we see today. Studying the oceans of 250 million years ago is important because it allows us to gain valuable insights into the present and future of our planet. The Permian period serves as a powerful reminder of the interconnectedness of life on Earth and the profound impact that changes in one part of the world can have on ecosystems halfway around the globe. Did you know that some of the tiniest animals on Earth today once had ancestors that were larger than life? From car-sized armadillos with deadly tail clubs to piranhas that could chomp through turtle shells, these prehistoric beasts were on a whole other level compared to their modern-day counterparts. Imagine you're swimming in a river 9 million years ago in what is now Argentina. Suddenly, you feel a sharp pain as a massive set of jaws clamps down on your leg. You've just become the latest victim of the megapiranha, a monstrous fish that makes modern-day piranhas look like guppies. Today, the red-bellied piranha is the largest species of piranha, reaching up to 50 centimeters in length. But that's nothing compared to the megapiranha, which could grow to a jaw-dropping 95 to 128 centimeters. This prehistoric beast was up to 4 times the size of its modern-day counterparts. But size wasn't the only thing that made the megapiranha a formidable predator. This giant fish also had an incredibly powerful bite force, 4 times stronger than that of today's piranhas. With jaws like that, it's no wonder that the megapiranha was able to hunt a wide variety of prey, including turtles, armored fish, and possibly even large mammals that ventured too close to the water's edge. However, despite its fearsome reputation, the megapiranha may not have been a pure carnivore. Like other members of the Cerasalidae family, it's possible that this supersized fish supplemented its diet with plant matter, making it an omnivore. Unfortunately for the megapiranha, its reign of terror came to an end around 6 million years ago, when it went extinct. The exact reasons for its demise are still a mystery, but it's possible that changes in climate or competition from other predators played a role. Today, the legacy of the megapiranha lives on in the form of its smaller but still fearsome descendants. Modern-day piranhas may not be as big as their prehistoric ancestors, but they're still a force to be reckoned with in the rivers and lakes of South America. Next up is an arthropod of monstrous proportions, the Arthroplura or giant millipede. This enormous creature stretches an astonishing 8.8 feet in length and weighs a hefty 50 kilograms. To put that into perspective, the Arthroplura was 27 times wider than the giant African millipede, the largest millipede species alive today. It's hard to imagine a millipede the size of a small car, but during the Carboniferous period, high atmospheric oxygen levels allowed arthropods like the Arthroplura to grow to these jaw-dropping sizes. Despite its intimidating appearance, the Arthroplura was likely a gentle giant. Based on the lack of fossilized jaws, scientists believe that this massive millipede was an herbivore, content to munch on the abundant vegetation of its time. Its size alone would have been enough to deter most predators, but the Arthroplura also had another trick up its sleeve. a durable exoskeleton that provided excellent protection against any would-be attackers. The Arthropleura may be long extinct, but its legacy lives on as one of the largest terrestrial invertebrates to ever exist. It's a reminder of a time when the Earth was a very different place, and the creatures that roamed its surface were unlike anything we can imagine today. Imagine looking up into the sky 305 million years ago and seeing a sight that would make even the bravest adventurer's heart skip a beat. A dragonfly-like insect with a wingspan of 2.3 feet soaring overhead. This is Meganeura, one of the largest flying insects to ever exist. At a time when atmospheric conditions were vastly different from today, with higher oxygen levels and a lack of flying vertebrate predators, insects like Meganeura were able to grow to sizes that seem impossible by modern standards. But Meganeura wasn't even the biggest of these prehistoric giants. That title belongs to Meganeuropsis, the largest known insect of all time. With a wingspan of 2.5 feet and a weight comparable to a modern-day crow, Meganeuropsis was a sight to behold. It's hard to imagine an insect the size of a small dog flying through the air, but during the Carboniferous period, it was a reality. Both Meganeura and Meganeuropsis belong to the extinct order Meganisoptera, a group of ancient insects that reach sizes far beyond anything we see today. These giant dragonfly-like creatures ruled the skies, likely preying on smaller insects and even small amphibians. Next animal on our list is Enhydriodonomensis, the giant otter of the prehistoric world. Today, the largest living otters, known as giant otters, can reach the size of large dogs. But even these impressive creatures would have been no match for Enhydriodonomensis. This ancient otter was a true behemoth, measuring up to 8.5 feet long and weighing over 200 kilograms. That's larger than a modern-day lion. Enhydriodonomensis was part of the Enhydriodon genus, which contains the largest known otters to have ever lived. But what makes this particular species stand out is its potential lifestyle. Based on an analysis of oxygen isotope ratios, scientists believe that Enhydriodonomensis may have been a terrestrial hunter and scavenger rather than a purely aquatic predator like its modern-day counterparts. This theory is supported by the giant otter's fearsome dentition. With bone-crushing jaws and potent canines, Enhydriodonomensis had the tools necessary to take down a wide variety of prey, both in and out of the water. It's possible that this giant otter hunted anything from fish and turtles to small mammals, and even juvenile hippos or crocodiles. The idea of a giant terrestrial otter stalking the African landscape is a fascinating one, and it highlights just how much diversity there has been in the otter lineage over time, from the small, playful otters we know today to the massive land-dwelling Enhydriodon omensis. These incredible animals have adapted to a wide range of ecological niches. Next comes Palearctomys, the giant squirrel of the ancient world. Today, most squirrels are small, agile creatures that scamper up trees and bury acorns, but there are exceptions, like the marmot, which can weigh up to 11 kilograms. However, even the mighty marmot would have been dwarfed by Palearctomys, which was twice the size of the largest squirrels alive today. This giant ground squirrel was similar in size to a large beaver, but with a lighter build that allowed it to move more easily through its forest habitat. It's hard to imagine a squirrel the size of a small dog, but during the Pliocene epoch, it was a reality. So what did this supersized squirrel eat to maintain its impressive size? Based on its dental morphology and the diets of modern-day ground squirrels, scientists believe that Palearctomys likely fed on a variety of vegetation, including grasses, herbs, roots, and flowers. It may have also opportunistically consumed eggs and insects when available. The existence of Palearctomys highlights the incredible diversity of squirrels throughout history. From the tiny acrobatic squirrels we know today to the massive ground-dwelling giants of the past, these rodents have adapted to a wide range of ecological niches and environments. Sixth animal on our list is Kumimanu bissae, the mega penguin of the ancient world. Today, the emperor penguin reigns supreme as the largest living penguin species, weighing in at an impressive 45 kilograms. But even the mighty emperor would have been dwarfed by Kumimanu bissae, which weighed as much as 3 emperor penguins combined. This colossal bird was a true giant of its time, possibly rivaling or even exceeding the emperor penguin in height. But Kumimanu bissae wasn't the only mega penguin to have ever lived. Another contender for the title of largest penguin was Palaeoludiptus klekowski, which stood an astonishing 6.6 feet tall. That's taller than most humans. It's hard to imagine a bird that size waddling along the shoreline, but during the Paleocene epoch, it was a reality. Based on their large bodies and the diets of modern-day penguins, scientists believe that megapenguins like Kumimanu biseye and Palaeodiptus klekowski likely fed on a variety of marine prey, including krill, squid, and fish. Some researchers even speculate that these giant birds may have been able to take down larger prey, like small sharks or dolphins. The existence of megapenguins like Kumimanu biseye and Palaeodiptus klekowski is a proof of the incredible diversity of life on Earth. From the tiny, adorable penguins we know today to the towering giants of the past, these flightless birds have adapted to a wide range of ecological niches and environments. Seventh and last one is Doedicurus, the giant armadillo of the prehistoric world. Today, armadillos are known for their small size and impressive armor, but their ancient relative, Doedicurus, was a different beast entirely. This massive creature was part of a group called the Glyptodonts, which were a clade of large, heavily armored armadillos that roamed the Americas during the Pleistocene epoch. Doedicurus was one of the largest Glyptodonts to have ever lived, weighing in at a staggering 2.6 tons and measuring 11.8 feet long from nose to tail. That's about the size of a small rhino. But what really set Doedicurus apart was its weaponry. This giant armadillo had a large spiked tail club that it could swing with incredible force. Scientists estimate that Doedicurus could whip its tail at speeds of up to 25 miles per hour, delivering a blow that would have been devastating to any predator or rival. It's thought that this tail club may have also been used in mating displays or territorial disputes. Despite its massive size and formidable defenses, Doedicurus was not invincible. This giant armadillo was preyed upon by fearsome predators like Smilodon, the saber-toothed cat, as well as early humans. However, Doedicurus was no easy meal. Its flexible spine allowed it to pivot quickly, and it may have even been able to stand on its hind legs to deliver powerful blows with its front claws. These giant creatures aren't just impressive in stature, they were also remarkably adapted to their environments with unique features like bone-crushing jaws, spiked tail clubs, and durable exoskeletons that allowed them to thrive in a world filled with danger and competition. Have you ever wondered what the oceans were like before whales dominated the seas? Prepare to be astonished by a creature that would have made even the largest whales seem small in comparison. Over 200 million years ago, during the Triassic period, a colossal marine reptile ruled the waves, Shonosaurus, the largest aquatic predator of its time. This incredible animal could grow up to 70 feet long, longer than a tractor-trailer truck, and weigh an astonishing 80 tons, surpassing the mass of a space shuttle. Shonosaurus was a true titan of the ancient oceans, and its story is one of the most captivating in the history of life on Earth. In 1920, a bizarre find in the last place you'd expect, the mountains of Nevada, far from any ocean. Colossal petrified bones were eroding out of the sun-baked rock, hinting at an animal of unbelievable size from an era long before humans. It would take another 56 years for paleontologists to finally excavate and identify these astonishing remains. In 1976, they announced Shonosaurus popularis, a new species of enormous ichthyosaur, to the world. So what was Shonosaurus exactly? Picture a dolphin-shaped marine reptile with 4 flippers, a pointy snout, and a powerful fin tail. Now scale it up to the size of a 5-story building, and you've got a rough idea. Early estimates based on partial skeletons pegged Shonosaurus popularis at a whopping 50 feet long and 25 tons. That's about the length of a humpback whale and the weight of 3 T-Rexes. But incredibly, an even more mind-blowing species of Shonosaurus was waiting to be unearthed. Can you imagine stumbling upon a discovery that would rewrite the history books? In 2004, just across the border in British Columbia, a groundbreaking find emerged that left paleontologists utterly astounded. Picture this, a colossal ichthyosaur skeleton, so immense that it made the previously discovered Shonosaurus in Nevada seem small in comparison. How gigantic was this newfound behemoth? Named Shonosaurus sicaniensis, this titan stretched an incredible 70 feet from snout to tail, surpassing the height of Italy's famous Leaning Tower of Pisa. But what about its mass? The estimates are almost too staggering to comprehend. Experts suggest that Shonosaurus sicaniensis could have weighed up to a mind-boggling 80 tons. Let that sink in for a moment. Not only did this make it the largest ichthyosaur ever discovered, but it also claimed the title of the heaviest marine reptile in Earth's history. How did it compare to other legendary giants like Mosasaurus and Megalodon, the biggest shark to ever roam the oceans? Astonishingly, Shonosaurus sicaniensis outclassed them all, firmly establishing itself as the unrivaled ruler of the prehistoric seas. As you might imagine, Shonosaurus sicaniensis' incredible size raised some eyebrows and taxonomic questions. Some studies in the 2000s argued its distinctive jaw shape made it a different genus, Shastasaurus, but a landmark 2021 study laid the matter to rest. This 80-ton juggernaut could only be the king of Shonosaurus. The superlative size of Shonosaurus hints at a truly gargantuan ichthyosaur fauna in the Triassic. Just recently, paleontologists discovered a single massive tooth in the Swiss Alps even bigger than any known from S. sicaniensis. Could it belong to an average-sized ichthyosaur with terrifying tusks, or a yet undiscovered titan that would dwarf even Shonosaurus? Tantalizing clues point to the latter, raising the astounding possibility of 100-plus-ton marine reptiles. So what was it like to be a Shonosaurus, the uncontested leviathan of Triassic seas? Surprisingly, for the largest aquatic predator of its time, Shonosaurus may have been a bit of a slowpoke. Its massive barrel-shaped body, lack of a stabilizing dorsal fin, and downturned shark-like tail paint a picture of an animal built more for cruising than chasing. But what Shonosaurus lacked in speed, it made up for in diving prowess. That deep, broad torso was perfectly adapted for withstanding the pressure and cold of the deep ocean, letting Shonosaurus hold its breath for hours while hunting at depths that would crush or asphyxiate lesser swimmers. We know it frequented deeper offshore waters thanks to the rock formations its fossils occur in. What could drive a colossal reptile as large as a bus and built for endurance to specialize in hunting within the dark, mysterious depths of the midnight zone? For years, the prevailing theory among paleontologists was that Shonosaurus used its immense size to its advantage, vacuuming up entire schools of soft-bodied prey like a gigantic toothless plankton eater. The supporting evidence? Some adult Shonosaurus specimens appeared to lack teeth, suggesting a filter-feeding lifestyle. Moreover, fossilized feces attributed to these ancient giants contained remnants of belemnites, extinct cephalopods that were the Triassic equivalents of modern-day squid and cuttlefish. But could there be more to the story of Shonosaurus dietary habits than meets the eye? But a few researchers have recently proposed a much more menacing mealtime for Shonosaurus. Telltale tooth sockets in the jaws of some fossils suggest it sported robust, deeply rooted choppers instead of bare gums. Juveniles and possibly some adults still kept their pearly whites too. And perhaps most convincingly, virtually every other ichthyosaur species we know of were active predators that seized and sliced their prey. Why should the most massive one be any different? Could it be that the gentle giant image of Shonosaurus was all wrong? Picture this instead, a gigantic Triassic terror, longer than a locomotive and many times heavier, rushing up from the depths to tear into schools of fish, squid, and even other ichthyosaurs with big blade-like teeth. Still a specialized hunter picking off smaller prey with surprising agility, but one that gulped and gored its victims down whole. The evidence is provocative, if not yet conclusive. But in the constant push and pull of paleontological progress, today's docile filter feeder may be tomorrow's macro-predatory monster. Equally alien to us is the world Shonosaurus inhabited. Rewind the clock 230 million years to the Triassic period. Most of Earth's land is mashed into the supercontinent of Pangaea, surrounded by an immense world ocean called Panthalassa. The rocks entombing Shonosaurus in Nevada and British Columbia once formed the seafloor just offshore western Pangaea. Bathwater warm seas thanks to a hothouse climate. Higher coasts carving unfamiliar shapes into the continents. Vast island chains spanning the horizon instead of ice caps. The Triassic Earth almost defies imagination compared to our modern globe. Imagine diving into the Triassic seas and witnessing an underwater world teeming with creatures that seem to defy reality. In this alien aquatic realm, Shonosaurus swam alongside a mesmerizing array of prehistoric companions. Ammonites, the spiral-shelled ancestors of modern nautiluses, glided gracefully through the water, their iridescent shells more dazzling than any contemporary cephalopod. darting past were improbably lizard-like fish, their scaly armor glinting in the filtered sunlight. Plesiosaurs, with their elongated necks and paddle-like limbs, cruised the ancient seas, hunting for their next meal. Phytosaurs, fearsome crocodile-like reptiles with razor-sharp teeth, patrolled the waters, ready to snap up unsuspecting prey. Primitive sharks and ancient swamp-dwelling fish pursued their quarry, adapted to thrive in a world vastly different from our own. In this Triassic seascape, the familiar sight of porpoises and tuna was nowhere to be found, replaced by an awe-inspiring cast of creatures that challenge our understanding of life in Earth's distant past. Tooth scars and broken bones in Shonosaurus fossils bear witness to the hazards of Triassic living. Even for the ultimate apex predator, fights with other carnivores risked lethal lacerations. Spine-swelling infections crippled even the unassailable. And for an air-dependent diver, the threat of drowning in rough seas was never more than a wave away. Giant size was no guarantee of an easy life. Yet Shonosaurus unquestionably reigned supreme in its slice of space and time, as unchallenged in its dominance as blue whales are today. For 10 million years or more, 60-foot ichthyosaurs ghosted through the tropical shallows and epic abyssal plains of western Pangaea, enduring as a dynasty of Triassic titans. But ultimately, even the most eternal-seeming empires come to an end. As Panthalassa gave way to the fragmenting continents and new oceans of the Jurassic 200 million years ago, Shonosaurus vanished abruptly from the fossil record, yielding its throne to the next set of giants. Whether it succumbed to rapid climate change, ecosystem disruption, or competition from newly evolved rivals is a mystery paleontologists are still seeking to solve. The scattered bones of Shonosaurus are all that remain of its astounding age, forever fixing in stone the memory of a world where reptiles, not mammals, explored the uttermost possibilities of ocean gigantism. A 70-foot, 80-ton ichthyosaur seems scarcely believable, more like a fantastic figment or fisherman's fable than a flesh-and-blood animal. But that's the magic of paleontology, the never-ending capacity of evolution's experiments to exceed our wildest what-if wonderings about the limits of life. The next time you find yourself dreaming up the most colossal creature to ever exist, consider the awe-inspiring Shonosaurus, a real-life leviathan that surpasses even the most fantastical sea monsters of myth and legend. Can you imagine a marine reptile of such extraordinary proportions, reigning supreme in the Earth's oceans long before whales ever existed? It's a humbling reminder that our planet has been home to amazing giants for countless millennia, long before humans walked the Earth. These awe-inspiring titans are not mere flukes of nature, but rather an enduring testament to the incredible resilience and adaptability of life on our ever-changing world. So as you ponder the mysteries of the ancient seas, remember Shonosaurus, a true legend as timeless and profound as the tides themselves. Ancient Egypt was a civilization that lasted over 3,000 years, and during that time, they shared their turf with some seriously cool critters. The Nile River and the seas nearby were packed with all sorts of unique animals that you won't find anywhere today. But here's the thing. As time went on, some of these amazing creatures started disappearing. They vanished from the planet, never to be seen again. Alright, let's kick things off with the elephant tuskfish, or as the ancient Egyptians called it, the Elephantidae piscis. This bad boy was an absolute unit, growing up to 20 feet long and weighing in at a massive 2,000 pounds. That's like having a small submarine with fins swimming around in the Nile. But the real showstopper was the elephant tuskfish's epic tusk. This thing could grow up to 6 feet long, and it was like a built-in weapon for hunting, fighting, and even showing off to potential mates. Talk about a fish with attitude. Now, the ancient Egyptians were totally obsessed with this giant fish. They thought it was the coolest thing ever, and they put it in their art and religion all the time. They saw it as a symbol of power, strength, and fertility, and they'd carve it into their temples and make fancy jewelry inspired by it. Some historians even think that the elephant tusk fish might have been the inspiration for the god Horus, who was half falcon, half fish. I mean, can you imagine a god based on a giant fish with a huge tusk? That's some next-level stuff right there. But here's the sad part. The elephant tusk fish ended up going extinct. As the ancient Egyptian population grew, they started overfishing the heck out of this poor fish. Plus, the Nile River started changing, with water levels going up and down and pollution messing things up. It was a recipe for disaster, and the elephant tuskfish just couldn't keep up. Even though the elephant tuskfish is long gone now, it left a lasting impression on the ancient Egyptians. They left behind all sorts of cool artwork and stories featuring this incredible creature, and it's a testament to just how mind-blowing the animals of ancient Egypt really were. So, as we keep digging into the wild world of extinct Egyptian sea creatures, just remember that the elephant tuskfish was the OG, the original gangster of the Nile. And trust me, there's plenty more where that came from. Next up is the Nile mega crocodile, or Crocodilus niloticus giganteus, if you want to get all sciencey about it. If you thought the elephant tuskfish was big, wait until you get a load of this guy. The Nile mega crocodile was an absolute behemoth, growing up to a jaw-dropping 30 feet in length. That's longer than a school bus. Can you imagine seeing one of these monsters lurking in the Nile? I'd probably need a change of underwear stat. But size wasn't the only thing that made the Nile mega crocodile terrifying. There are actual accounts of these beasts attacking boats and causing some serious panic among the folks living along the Nile. I mean, if I saw a 30-foot crocodile coming at my boat, I'd probably just accept my fate and hope for a quick death. The ancient Egyptians must have been pretty freaked out by these giant crocs too. I can just picture them sitting around the campfire, telling stories about the massive crocodiles that could snap a boat in half with one bite. It's no wonder these creatures became the stuff of legends. But just like the elephant tuskfish, the Nile mega crocodile couldn't outrun extinction forever. Scientists think that a combination of overhunting by humans and competition with smaller, more adaptable crocodiles eventually did them in. It's like the reptile version of David and Goliath, except in this case, David won. It's crazy to think about how these two incredible creatures, the elephant tuskfish and the Nile mega crocodile, once ruled the waters of ancient Egypt. Can you imagine if they had ever come face to face? It would have been an epic showdown for the ages. Alright, the next contender in the extinct Egyptian sea creature Hall of Fame is the Pharaoh's sea serpent, or Aepyornis aegyptiacus. This thing was like something straight out of a mythology book, and trust me, it's going to blow your mind. First off, let's talk about what this creature looked like. Imagine a giant serpentine body, but instead of a snake's head, you've got a head that looks more like a horse. I know it sounds crazy, but that's exactly what the Pharaoh's sea serpent was rocking. It's like Mother Nature decided to mash up two completely different animals just for the heck of it. Now, the ancient Egyptians were all about this sea serpent. They believed that it was a protector of the pharaohs, kind of like a massive, scaly bodyguard. There are even depictions of the pharaoh's sea serpent in ancient Egyptian art, where it's shown coiled around the pharaoh, ready to strike at any would-be assassins. Talk about a loyal pet. But here's the thing. Just like the elephant tuskfish and the Nile mega crocodile, the pharaoh's sea serpent eventually disappeared. And when I say disappeared, I mean it vanished without a trace. Like one day it was there, chilling in the Nile and protecting the pharaohs, and the next day, poof, gone. Scientists have a few theories about what might have happened to the pharaoh's sea serpent. Some think that climate change could have done it in, while others believe that overhunting might have been the culprit. I mean, if you're a pharaoh and you've got a giant sea serpent protecting you, you might get a little overzealous with the whole hunting your enemies thing, right? Regardless of how it happened, the fact remains that the pharaoh's sea serpent is long gone, and we're left with nothing but legends and artwork to remember it by. It's kind of like the Loch Ness monster of ancient Egypt, except instead of a Scottish lake, it was the Nile River. Alright, our next extinct Egyptian sea creature is a real doozy. Get ready to meet the Nile River whale, or Neobalena nilotica. That's right, you heard me. A whale in the Nile River. Now, I know what you're thinking. A whale? In a river? That's crazy talk. But hear me out. The Nile River whale was a real thing, and it was actually pretty small compared to the whales we know today. These little guys only grew to be about 10 feet long, which is basically a baby compared to the massive blue whales that cruise around the oceans now. But what the Nile river whale lacked in size, it made up for in uniqueness. You see, this was a freshwater whale species, which means it lived its entire life in the Nile River. It didn't need to swim out to the ocean to find food or mate. It had everything it needed right there in the river. The ancient Egyptians were big fans of the Nile River whale. They used to hunt these little whales for their meat and blubber, which they used for cooking and lighting lamps. They even featured the Nile River whale in their artwork, which is how we know what they looked like. But just like so many other incredible creatures that once called Egypt home, the Nile River whale eventually went extinct. Scientists think that a combination of overhunting by humans and changes to the Nile River's ecosystem probably did them in. It's a sad story, but it's one that we see repeated over and over again throughout history. From giant crocodiles to tusked fish to river whales, the waters of Egypt were like a real-life aquarium, filled with creatures that seem almost too fantastic to be real.